Hello and welcome to the project on IMDb movie rating prediction. So in this session, we are going to use machine learning models and predict the movie ratings. So we are going to predict the IMDb ratings of a particular movie. So let us start with importing the libraries. As you can see here, we are predicting the number which is nothing but IMDb score. So this is a regression problem. And in order to work on this model, we have to import all the necessary libraries. So as you can see, here I have imported Numpy as NP, where Numpy is nothing but a Python library which helps us to work with arrays. Basically, Numpy stands for numeric Python, and it also helps us to work with matrices and algebra. Next import is Pandas. It will help us to create the data structures and also help us to manipulate these data structures, like dropping a column or editing the column name. Then the next one is C1. So C1 is a Python library which will help us to visualize a statistical graphs, and it is based on matplotlib library. The next library is matplotlib.python, which will help us to create charts. And the next import is warnings. So when we run over this machine learning model, we are given with some warnings, and when we import these warnings and use warning.filter warning, we can ignore such warnings by using this code. The next import is label encoder, which is imported from sklearn.preprocessing. This library will take only categorical column and convert them into numerical one. And the next import is train test split. We have imported this from sklearn.model_selection. So let us say if we have a data frame, we can split our data into test, train, split. It will help us to split the data into training and testing parts, which will be used for machine learning algorithms. We have imported the linear regression model, and we have also used decision tree regressor over here, and we have used random forest regressor as well as k-neighbor regressor. So in the end, we are going to use XGBoost over here. So when it comes to regression, they will help us to predict the number. So let it be sales price or IMDb in our case. For such cases, we use this regression model. But when it comes to classification, once the classification model to be predicted label whether the output is going to be yes or no. If a person is infected with a disease or not, such problems we use something called as classification. So now we are treating it with IMDb score. For that reason, we have used the regression model over here. So starting with regression models, what is a linear regression? It is a supervised machine learning algorithm where the predicted output is continuous and have a constant score. And then the second import over here is decision tree regressor. Decision tree regressor can do both regression and as well as classification of the model. This model does it that it breaks down our dataset into smaller and smaller subsets, while at the same time associated a decision tree is developed. And then we have imported other random model, that is random forest regressor. So random forest regressor is a model estimate that fits the number of classified decision trees on various subsamples of the dataset, and it uses averaging to improve predictive accuracy and the control over fitting for decision progressor or decision tree classifier, and prone to overfitting, and that problem is not seen in random forest regressor, and it never gives us overfitting problem as compared to the decision tree regressor. And the next import is k-neighboring regressor. So when it comes to k-neighboring regressor, it is a non-parametric method that is an intuitive manner approximates in k-neighbor regression, which is a non-parametric method that in an intuitive manner approximates the association between independent variables and continuous outcome by the averaging observation which are in the same k-neighborhood. So this is k-neighbor regressor over here, and then we have imported the XGBoost, and it is a decision tree based and simple machine learning algorithm that uses gradient boosting framework, and the algorithm differentiates itself in the following ways. It is used in a wide range of applications, and even the XGBoost can be used for solving regression, and we can use this XGBoost classifier to predict a classification problem as well. So the random forest regressor and the XGBoost regressor do not overfit. Random forest regressor can be used for regression and the classification problems, and it provides a higher accuracy to cross-validation, and it will also handle the missing values. So even though we have a missing values, random forest will take care of it in both regression as well as in classification problems. And these models that we have used for machine learning will be evaluated in order to compare that which model is being performed well. So to know if a model has performed well or not, we will use some evaluation methods. So over here we have imported something called mean squared error, and then we have used accuracy score, and then R2 score, and next mean absolute error. So these evaluation matrices will tell us whether the model is performing well or not. So when it comes to mean square, the mean square error is an estimator of a measure, and it measures the average of a square of the error. And then we have the accuracy score here, which will tell us how accurate that model is. And then we have something R2 score over here. So when it comes to R2 score, the higher the R2 score, the better the model performance is. And the R2 score should be closer to 100. If the R2 score for a particular model is less, then we have to do future engineering or improve the model. The higher the R2 score, the better the performance of the model. So next we have absolute error. When it comes to the mean absolute error, it is a measure of errors between paired observations expressing the same phenomenon, and we are going to do the accuracy score. So how accurate are the models? So the other evaluation matrices that can be used over here are RMSE. The R2 means the square error. The lower the RMSE score, the better the model performance is. And these are over here actually done nothing but our evaluation matrices. So let us run this cell and import all our libraries. So let us run this cell and import all our necessary libraries. So moving forward, we will load our data. So before we load our data, we use pd.read_csv code to read our CSV file, and the data is for the movie metadata set.csv, which is in the CSV form. So this is our data. So the data set is loaded, and next pd.set option, and it displays the maximum number of columns. So in order to see all the columns, so we have stored the data basically into df. So this is how our data looks like. So we have color, director name, critics for review, likes, and so on. And at the end we have IMDb score, so which is our dependent variable, or it can also be called as a target variable. And the remaining variables, some of the independent variables that are movie link, language, country, origin. So country, origin, language, all these are independent variables. So this is how our data set looks like.